Our special guest today on the AI Risk Reward podcast is Professor Agostino Capponi. He is the director of the Center for Digital Finance and Technologies at Columbia. So we're going to do a deep dive into risk management of AI in finance, which includes AI governance, agentic AI finance, and know your agent as agents start doing finance and shopping and cool stuff like that. Enjoy the show. Welcome, everyone, to the AI Risk Reward podcast. And our special guest today is Agostino Capponi, professor at Columbia University and director of the Center for Digital Finance and Technologies. Welcome.
Thank you, Alec. It's a pleasure to be here today.
Yeah, so I thought today we'd really do a deep dive in AI governance and risk management for AI. But first, tell the audience a little bit about the Center for Digital Finance and Technologies at Columbia.
Yeah, so the Center for Digital Finance Technology at Columbia was founded by myself around the end of 2022. And the objective was essentially to become a hub for promotion of research, education, and teaching in the space of digital finance, broadly speaking. So under this umbrella, we classify the emergence of the new financial technologies like digital payments, digital trading, including the crypto and blockchain, let's say, marketplaces that have been emerging. And then in addition to that, we also have AI and finance. So we want to understand exactly what's the usefulness of new technologies based on agentics and other classical machine learning techniques or methods for investment, risk management, and trading. And the center basically includes a number of faculty who are all working on areas related to digital finance, as well as a number of PhD students, postdoc, again, active in the space. We organize events, conferences. We partner with members from the private sector who contribute to our research agenda, as well as participate in our events, sponsor research, a number of other initiatives.
Wow, that sounds amazing. Congratulations. It's such a hot area, and it's going to be so important as well. I think that my opinion is that the big AI companies are not really thinking that hard about this. They're, in an AI race with each other in China, and it's really up to you and me and other people, researchers in the field, to really focus on governance and model risk and things along those lines. So in terms of governance and model risk, are there any particular frameworks that you focus on or have developed at this point?
Yeah, in terms of governance and model risk, I think the objective of what we have been looking at mostly is basically understanding how is the rapid adoption of AI impacting the way we do risk management and governance. I think the focus has been a lot on understanding, for example, how we can leverage the modern machine learning or AI techniques for trying to somewhat be as model independent as possible. So when we, for example, compute, we do stress testing, or when we do trading, we want to do portfolio optimization. We want essentially AI agent to understand or to guide us in terms of what, for example, assets to pick before we do the portfolio optimization. Or can we leverage, let's say, the impact of news or other information that is available on the web, of course, controllable and trustworthy information to, for example, select beforehand a set of assets that we can invest on. So in addition, one of the projects we are currently working on is exactly using AI agents to screen out the good stocks that we want to invest on, which means the ones which are more predictable, more forecastable. And then after we have done this, after the step, understand how we can implement the classical, for example, portfolio optimization models to select the best portfolio possible. So that's just one example of how we use AI, for example, for portfolio management. Another project that we are currently working on is also related to leveraging techniques from machine learning and AI to essentially have the data inform what's the best like model to use. So in other words, we don't really want to make a specific assumptions about the model because there is a lot of model risk involved, especially when you try to understand, for example, what would be the change in a portfolio if there is a shock in the market, right? Typically, you have to make some assumptions on how the market is responding to these shocks, or how like the market is behaving before the shock occurs. Here, we are trying to understand what happens if you just observe the data historically, and then you try to somewhat embed your embed your data into, let's say, a space where we try to leverage or take into consideration only the data that we are observing at the moment in order to make forecast or make assessment about how the portfolio is going to change in the future. For example, we have leveraged some techniques from signal processing, which go under the name of embeddings. Essentially, these embeddings are ways to take the data, go into a separate different space where the state of the system is captured only by like summary representation of the data, which capture the intrinsic structure that we observe, and then use those to make predictions about what is going to happen if there is a shock in them. So we try to map from the physical space where we observe this data to another space where it's easier to propagate and project other things.
Yeah, that's very interesting. So one of the hot topics right now in AI is explainability, meaning the AI says, hey, these are the stocks that you should look at. But then, being able to have the AI explain, well, here's why I picked those stocks. Here's the features that made them attractive. Is that something you're also working on at this point?
Yes. We have looked at the interpretability in different contexts. Let me give you maybe a couple of examples of projects that we have been looking at interpretability. The first is using agentic framework to explain decisions. So this semester, I taught a class at Columbia called Agentics AI, FinTech and the Data Economy. And one of the objectives of this class is exactly to expose students to how to use agentic techniques, how to deploy agents, how to how to construct agents, and how to use agents for decision making. And all of this is basically leveraging the fact that we need to be very careful when we design these agents, because we need to understand exactly what tools they are using and what data they are using. So I think any agentic framework makes sense if you specify exactly the tools, which are essentially functions, methods, any other procedure that is involved by the agents to solve a specific task, as well as the data, because if the quality of data is not good, then of course the decisions that will be made are also questionable. And we have used the agents to give explanations. So for example, we were trying to build a portfolio interface that is currently now released as open source software on the center's website, where we allow a user to ask questions. For example, like, can you please come up with a list of stocks that we should focus on in the tech sector? So then the AI agent comes up with an answer by looking at news, by looking at data that are available in the market, let's say S&P 500, Bloomberg News, Thomson Reuters News, and it gives an answer, saying, for example, okay, I think you should focus on, let's say, NVIDIA, Microsoft, Google, and you should reduce your attention on, let's say, Apple or others. Like, it gives basically an answer of this sort, and importantly, it gives you an explanation for why it's suggesting to use this stock. So that's, I think, one version of interpretability, in that where every time the AI agent is making me a recommendation, it's also using text, structured data to come up with an explanation for that.
Yeah, that makes a lot of sense. Yeah.
Yeah. And I mean, we have done also another project that is, again, also released open source as a software interface that you can one can play with. And we also wrote a short paper about it on how we can use agents to give explainability for decisions that you make in prediction markets. So prediction markets, just to give a brief background, are essentially market of the truth. If you want to, let's say, bet on the outcome of an event, let's say who will be the next president of the States, or who will win, let's say, the next World Cup, then you can participate in this market and you can buy two types of token, yes token or no token. If you buy a yes token, this will pay you $1 if the outcome happens to be yes. If the answer to this question happens to be yes, and it will pay $0 if the answer happens to be no. And vice versa, if you buy a no token, you will get $1 if the outcome turns out to be a no. Now, what we have done using agentic is we have taken like a number of bets coming from one of the main prediction market, which is called Polymarket. It's a market deployed on a blockchain. And we have tried to use agentics to explore relationships between different bets. So we have told the agents, can you please tell us what of those bets have a relationship, so that if I invest, let's say, and buy a yes token in this market, then I should also conditionally invest on this other prediction market and buy a yes or no token when the first market resolves, when the outcome of the first market resolves. And the agent gave the agentics gave a very good semantic understanding of what bets are correlated and what bets are not. Not correlation in the traditional sense, but correlation in terms of just looking at the sentence and the news. They basically come up with an explanation for why two bets are correlated. For example, if one bet was will Trump meet Putin before June 2025, and will Trump stop sanctions on Russia by, let's say, April 2025, it would tell us that these two bets are positively correlated, because if he stops tariffs, then it's more likely that he will meet Putin. So just to give an example, like he just uses the structure and the information to come up with first of all, to come up with an answer, and second of all, to explain why we believe that these answers are correct. So these are just two examples of where you can use agents to give explainability. And
that's great.
Yeah, and I want to mention a third project, which is a little bit less on AI agents, but more in terms of explainability, in terms of machine learning, where we have tried to see how much we can improve in terms of Sharpe ratio and portfolio construction if we leverage information coming from the supply chain. For example, if we know that companies are related to each other because they have buyer-supplier relationships, how is this information going to help the construction of high-performance portfolios? And we have basically shown and seen that once you account for supply chain relationships as an additional factor in your portfolio, then you will be able to actually attain larger observable Sharpe ratio. You will be able to improve the performance or the returns of your portfolio. And then we asked the machine learning algorithm, can you give us an explanation on what this supply chain factor represents? Is it capturing how central this firm is in the network of relationships? Is it capturing, let's say, how important is this firm in connecting between different sectors? And then we found that we are able to essentially get explainability in terms of supply chain factors using modern machine learning techniques.
Yeah, it totally makes sense. Now, as one of the things that is interesting to me, but kind of geeky, is that a lot of the data providers are out there, and they've added to their contracts for financial companies something that says, you can use our data, but you're not allowed to train AI models with our data. So this is becoming very common. And, so now if I'm at a large financial institution, I've got data coming from everywhere, right? Like I may not be aware that some data that I have came from a source. It doesn't allow me to use that data to train an AI model, right?
Yeah.
Now, and if that vendor comes in and does an audit, they may discover that. I may be in trouble. So are you thinking at all about data lineage at large financial institutions, like what you can train with, what you can't, what you can substitute? Is that something that you've focused on at all?
I'm not focused exactly like on this federated type of learning based on data, but I have some opinions about it. I mean, I think there is a questions about privacy that is extremely important, and there are there's a lot of debate, and I also believe that one has to distinguish between using like the data for their own decision-making process and using this data to train AI models, right? Because once you use this data coming from external sources to train AI models, the AI model incorporates this data, and as a result, the data is no longer private. And I think this lack of privacy is exactly the main problem at the moment. Like, we need to basically make sure that the data is viewed as a commodity or as an asset, and as a result, it has to be also, one has to design the limits on usage of this data. There are like techniques, for example, to limit the amount of information leakage that you have once you use this data for training. For example, you could try to only use some part of this data, or protect in a way, let's say, the anonymity of this data in your training model, while still taking advantage of this data to best train your model without, let's say, leaking too much information. I think this is like one of the topics that is important, like come up with privacy preserving mechanisms. I've investigated this to some extent in the context of payment systems. For example, when you make payments, you have two forms of privacy, right? You have identity privacy, you have transaction privacy. I can protect my identity, or I can protect the content of my transaction. And the question comes up in terms of like, can we somewhat design payment systems where we are like we are still able to make gain efficiency, make sure that everything is auditable, that we reduce the amount of illicit activities. We allow government regulators to check, let's say, on the integrity of this transaction, while at the same time protect the privacy of those users who don't want to, for example, reveal who they are or what transactions they are making, not because these are illegal but or illegitimate, but just because they want to protect, let's say, the business that they are doing. So that's...
Yeah, I mean, look, the good news in terms of AI and payments is we already have a regulatory structure in the US that addresses this. So we don't have to make up or imagine what the new rules might be. And there's really, Reg E governs this, and there's really around electronic fund transfers. And there's really three parts, right? One is consumer protection, right? So if there's an illegal transfer or another unauthorized transfer, whether it's a debit or an ATM or an ACH or a person-to-person transfer, if the consumer reports it and says this is fraudulent, that the bank has to effectively, make them whole or, recompense them based on, really the liability gets capped based on how quickly the consumer reports the issue. Second, if there is an error, meaning I didn't do anything, but magically money is taken out of my account because the bank made a mistake, obviously they need to provisionally credit the consumer, they need to fix it, all those kinds of things, and provide an explanation of what happened. And then finally, there's a lot of disclosures that banks need to provide. Obviously, every year I get that stupid pamphlet in the mail from a bank that says, here's our privacy notice, it's 8 pages, no one reads it, they throw it away immediately, but that is required by law, as well as periodic statements, transaction histories, and making sure consumers can look at that, the account information, obviously, and be able to spot things that are wrong. So as we move to agentic AI and move to agents doing things for consumers, there's a lot of questions, like how does Reg E, obviously Reg E applies, but does it apply to an agent as well as a consumer? Who's providing the agent? In other words, if I'm a consumer, is Chase Bank providing me with an agent to use with my bank account, or am I getting that from Google or Amazon, right? So there are a lot of questions about where that's going to come from. Or what if I build my own, agent that can go shopping? So I think there's a lot of, law and governance and risk management, still to come in this space, because we don't even know today, like who might be liable if an agent that I build goes out and I tell it it's got $100 budget and it spends $1,000 on a pair of sneakers, right? Like I don't know, right? Like if I built it, it's probably me, but what if Chase built it, right? Like, so I think there's a lot of kind of, a lot of things we just need to figure out over the next couple of years as agentic AI in the payment space and the shopping space goes from no one's really doing it to a few years from now, totally normal.
Yeah. No, I agree. I think one of the killer applications, in fact, of agentic AI is exactly e-commerce, right? I think it has a lot of potential to change the way we do e-commerce, simply because it makes things more efficient. Like you can deploy AI agents who can basically get much better at understanding what are the best deals, as well as to make maybe suggestions when I'm making, let's say, of course, I can imagine that if I'm, let's say, buying products on Amazon, before like checking out, maybe they make out recommendations. Okay, you can also take advantage of this offer and maybe add this product to your like basket before checking out. And of course, that's I think is really the benefit of agentics. That's one of the main benefits. On the other end, I agree with you that the question is a question of governance or liability becomes very important, because if something happens, let's say if an agent is somewhat programmed with malicious behavior, which is likely to happen because, of course, even if technology makes progress, there is also some parties which try to take advantage of this technology to conduct illegal activities. Then the question is, who is liable for that, right? Because the AI is the AI. Should we regulate an AI agent? And what are the consequences if this AI agent behaves maliciously? Or should we regulate the company or the party who is deploying this AI agent? So I think these are like super important questions that need to be addressed if we want really to gain broader adoption. Because if we don't do that, then the technology has a lot of potential, but if there is a lot of worry about like intended behavior, then I can imagine that maybe most of the e-commerce giants at the moment might be very reluctant in allowing agents to contribute.
Yeah, I mean, part of that's really going to be security, right? And cybersecurity. And, one of the things many people are talking about today in cybersecurity AI circles is know your agent, right? So we have know your customer in banking, meaning when I want to open an account, I've got to show an ID, I've got to give them my social security number, I have to prove that I'm really me. And only then can I open a bank account in the US, right?
Yeah.
So know your agent would be, okay, if I'm going to go shopping and my agent's going to go shopping, how do I know that's really Amazon's agent that's going to sell me something? And how does Amazon know that my agent is real and will really actually pay money for something and that they really should ship it to my address? So this is just a brand new area where I think the good news is we have things like Reg E, which kind of still apply to AI agents in terms of like, hey, how do payments work? And what are the regulations about that? How do we protect consumers there? But the technology in terms of how do two agents know that they're talking to legitimate counterparties, that part is undefined at this point.
Yes, absolutely. I think that's really where I think as with any new technology, it's always a question of understanding what are the limits and what are the rules, the governance rules that need to be followed when you use it. I think once these are clarified, then of course the adoption will start increasing. I think this is the same for like other modern technology that we have seen emerging over the years, including, for example, the crypto technology, right? If you don't regulate them, then it's unlikely that you'll have adoption, precisely because many of these companies are subject to strict regulatory scrutiny, and you have to justify, like, you have to, when something happens and you go to court, you need to be able to make a strong case.
Yeah. So turning to cybersecurity, right? This is going to be super important in finance, right? Banks are worried about data exfiltration. They're worried about people hacking into their system and, corrupting a model. They're worried about data poisoning. So what are your thoughts about that? How can financial institutions going forward create robust cybersecurity protections against different types of threats to Gen AI?
Yeah, that's a very difficult question to answer, because I think when it boils down to cyber, I always think about operational risk, and I think this is always a question, because we don't always observe the same threats. So sometimes we see some form of data that breaches or data that are stolen, or like software like manipulation. So these are all events which are different from each other. I think one of the solutions that I always think is try to invest in prevention, try to understand like what type of systems or jailbreaking or system you can put in place to limit the consequences of an attack. For example, like if some attack happens to your company, is it possible to limit the consequences that you bring on other companies? Because of course you are like connected to others in a network. And one of the questions is, can we try to limit or insulate in a way the risk, the operational risk that the company is facing from the rest of the system? Can we avoid that this becomes systemic if it happens, right? That's, I think, one I would say important questions that even regular authorities should think, like how to make sure that this company operates as islands in terms of data, like even though they are connected to the rest of the system, so that if an event happens to one of companies or the firms, it's not really propagated systemically to the others. I mean, that's, I think, what one can do. In terms of like ex post resolution, because there is a question of ex ante prevention, which I think is, in my view, the most important. Then there is a question, okay, if something has happened, how do we resolve the problem? So ex post resolution. And here, I think it's like a little bit more difficult, because these events, these data breaches have like consequences which are not easy to resolve. And as a result, like here, we need to basically understand more how we can somehow again limit the damage once it happens. I think it's very important to also design software systems which are able to somewhat revert back to the history prior to the occurrence of an accident. Like, can we try to improve the quality of our software? Can we maybe even use agents, right? AI agents that are able to somewhat backtrack the occurrence of a problem and try to restore the system to going concern.
Yeah, that totally makes sense. Super, super important, being able to revert. It's kind of a standard software protocol and has been for decades. But only now are people in AI like, oh, we need to be able to revert if there's an issue. And also you look at even the base models, they're deprecating the old models so quickly. You could be using a model today that's current that literally will not be available a year from now. So at some point you're effectively forced to move to a new model. Look, I think this brings up a key question, which is, as we all know, and our listeners all know, large language models are non-deterministic, right? They're not going to give you the same answer over and over again. They're going to give you a slightly different answer as long as the temperature is not set to one of the model. So as we move on to new versions of the model, or the questions change slightly, or the data inputs change, like how can financial institutions validate the models and make sure they're working properly? Obviously, there are eval tools out there and things like that. And what standard should they be held to, right? So I go back to the old story of when AT&T was building out the telephone system in the US, they actively chose a standard, which was 5 nines of reliability, 99.999%. If you pick up the phone, there's a dial tone, you'll be able to call someone. Because they viewed it as a national security issue. The president has to be able to call someone, right? That's clearly not where we are with large language models right now. We're not at 99.999% accuracy. So to some extent, it depends on, hey, what use cases are you picking, right? If I'm picking make my grocery list or write a poem and it's 95% accurate, I'm going to be okay, right? If that is granting a loan to someone, obviously I want a much higher rate of accuracy. And also, obviously, in some cases, a human in the loop, right? Where if it's making a critical life or death decision, or maybe something as important as granting an individual a mortgage loan, like it can't just be AI with zero oversight, or we're going to run into potential issues of either it just gets it wrong, or bias, or a lack of accountability. And we talked about explainability before, but now let's talk a little bit more about how the models are non-deterministic and how we can validate them, or what can we do to get them to higher accuracy in runtime, not just in building a model and training it.
Yeah. No, these are good questions because, as you mentioned, with most of the LLM or AI models, the answer is not deterministic, right? If I and you ask the same question to them, we are likely to get slightly different answers. I think what this speaks to the question of how can we define benchmark that we could use across the board, where we're able to say, okay, this model, if we want to validate the accuracy of this model, we can trust that this is giving the right answers. I think that's basically boils down to questions about maybe defining this benchmark in a probabilistic manner, similar to your example about agentic, that basically was giving a 99% confidence in the decision. I can imagine that something similar should happen for models based on AI, where we can say, okay, if let's say after wearing the model 99% of the times, you get this answer, or you are able to pass a specific set of checkpoints, then you can validate and you can claim that this model is behaving as it should. There's a result, it passes the safety question. Basically coming up with a set of, again, set checkpoints that it has to be satisfied to qualify for a safe, trustworthy, and reliable model. Let's say to be sure that I can say, okay, I validated and it's accurate. This can be done, in my view, probabilistically specified, very high confidence. In a way similar to what banks do right now. Also, when they do stress testing, they say I want 95% of the times to make sure that I have enough capital is something. So I think the same analogy works for models. I want to make sure that 99%, 95% of the times, then the model responds or passes the set of criterion that I decide to be valid for a good model to be valid. And of course, depending on the criticality of the applications, we could design this threshold to be higher or lower. For example, if it's really an AI model which is making a decision which is super important, super critical, that can have huge systemic consequences if it's wrong, then you want to increase the threshold to, let's say, 90%. If instead you are using the AI model to make a recommendation which is not necessarily life-threatening, which basically might result in some maybe loss of money for one of the stakeholders or one of the party, then you can lower this threshold. I think that's basically one way I can view the model to be validated. And then the other important point is because these models are non-deterministically, I think we need to design a set of prompts each is using. Like when we validate this model, when we try to see whether or not they are compliant, then we should make sure that we are not really prompting all these AI model in a different way. Because if you give if I and you give a different prompt, of course we are going to get a different answer. So we should standardize the set of prompts that are used at least in the validation stage. Then when we use them for our purpose, we can use it in prompting in any way we want, because we have, depending on the prompt that we give, we are going to give to obtain completely different branches, completely different developments. But if we want to validate them, we should agree on a set of legitimate prompts that we give to the models.
Yeah, I mean, I think that's an excellent thought process there. One of the things I get concerned about, if you look at the large company-based models right now and how they're really accelerating on the different tests, humanities last exam, all these, programming tests, all those kinds of things, they're doing better and better. And what I worry about that it's kind of like, the SAT exam in the US where you can train to the test. Like, here's 100 questions. I'm going to teach the AI how to answer these 100 questions to the exclusion of teaching it how to do other things, because I know that I need to get a good score on this specific test and I know what the questions are. So that's a little bit what I get concerned about there. Is that something you've thought about, how to bypass that problem?
Yeah, so I think this is a question of we want to use the AI agent not really to replace the human completely, right? For example, for the IT, of course, we would like the student to perform well because he's aware of, he's learned the knowledge rather than maybe being replaced by an AI agent to memorize this and is able to answer this question on his behalf. I think that's important. I think that's basically about setting the boundary. We should try to make sure that these AI systems are supporting rather than replacing the human. As a result, we should make sure that they can assist. For example, I don't see any problem if they assist a human in solving some of the questions that come up in an SAT test, even because I foresee a future going forward where we are no longer independent in solving problems or questions, but we are still cooperating with a different person, which is in this case the AI agent. I view him as a collaborator. So as a collaborator, he can help in the decision-making process. He can help in answering questions in a test. There is no problem with that because a test to me is designed to basically test your knowledge so that you are able at performing well in a job. It could be performing well in education, performing well at work. And going forward, we will all have AI agent to work with us, right? They participate in meetings, they take notes, they interact. As a result, if they act as a collaborator rather than as a substitute, then I view this as perfectly legit. So just a question of writing the beat, clarifying the boundary between collaboration and replacement. I think if we are able to do that, then I can see the agent being a supportive as opposed to be, let's say, something bad.
Yeah, totally makes sense. So as we think about regulation, then should it really focus on the models themselves or the use cases or the outcomes, if you had to pick one of those?
I think we should focus more on the model because, again, I always think that we should solve the problem ex ante rather than post. If we focus on the outcomes, then again, we observe two different outcomes, but we don't know how they have been produced. So it's difficult really to regulate or to impose governance on. Whereas if we focus on the model and we essentially say, okay, this is how we should standardize governance in a way that we are able to supervise and validate these models. I think it's easy, it's more transparent because we can observe the models. Like at least we know that behind each model, there is some underlying software or hardware infrastructure. And as a result, if there is a problem, you are able to detect it more efficiently. If we look at use cases, of course, it would be difficult because then we have so many different possible use cases that we can design. And then even if you set a standard set of use cases, somebody can come up with a different use case, which is not in this class. And if it breaks the system, then what do you do?
And now a word from our sponsor. Artificial Intelligence Risk Inc. accelerates adoption of GenAI safely. They provide the governance, risk, compliance, and cybersecurity platform that financial, healthcare, and other regulated organizations need before they can use GenAI safely and in compliance with regulatory requirements. Their software has won #1 awards for cybersecurity and compliance from Waters Technology. find them at aicrisk.com. Yeah, that makes sense. Yeah, and then you think about it more broadly, right? About responsibility and like think about there are a lot of people in finance that have a fiduciary duty, right? So if you're a financial advisor and you have a investor who's a consumer, you obviously owe them a fiduciary duty. If you're starting to use AI to do different things like help you invest or communicate with your investor or eventually execute securities trades, like how is that how's that aligned, right? Like who's eventually responsible? Like how should we think about that as a framework? Where does the fiduciary duty of a financial advisor stop, right? Like where is someone else effectively responsible?
Yeah. So that's again, right. So I think that's one of the main questions, like what's the boundary of the fiduciary duty? Where does if I am, if I have a financial advisor and I'm actually responsible for whatever decision recommendation I made to a client, but then there is an AI agent who is also participating in the process. So who is responsible for, let's say, decision and a recommendation that I made to an investor or client? I think that's, that really boils down to understanding what are the boundaries. It also depends on how much the financial advisor is interacting with the AI agent. So if like a lot of in an ideal world, if for example, like financial advisor is giving recommendation up to some point, and then later point, if he needs to give more detailed recommendation is using an AI agent, then it's easier to define the boundary because he can say, okay, up to this point, I'm liable for whatever happens. So that's where my fiduciary duty stop. And then from that point on, it's basically the robot or the machine which is responsible for decision making. But again, this also and this question also depends on whether the AI agent is treated as an entity and therefore as liabilities rather than support for the financial advisor. If it's viewed more as supportive of the financial advisor, then the entire responsibility is on the financial advisor and how he is delegating some of the responsibilities to the AI agent. If instead we view the AI agent as a standalone entity, which has also liability, and the result, it has to be part of this regulatory process, then I think it's basically a question of designing what are the boundaries, the interactions of the two.
Yeah, and as you look at both public and private companies, boards of directors are ultimately responsible for risk appetite.
Yeah.
Right. So as companies onboard AI, choose what to do with that, choose AI agents, choose providers, choose use cases, choose whether to do things internally and externally. It's going to be super important for them to really understand what's going on. So as we think about AI accountability, what are your thoughts in terms of how should boards think about this? What kind of framework should they look at? And how deep into the weeds does a board need to get to understand what's going on with AI and make sure that what they're comfortable from a risk appetite standpoint is actually what a company is doing?
Yeah, I think this is an important question because first of all, I think we need to understand whether or not this board of directors who are ultimately responsible for the oversight of the entire risk process of the firm is participated by AI or not, right? I can imagine going forward that part of the governance decisions are actually done by AI agents. So maybe the board process is not only consisting of a human, but it could be consisting of a mix of human and AI, or it can even be completely automated by AI agent who are just making the right decision, and then there will be some human supervision at the end to just check out through the process. And in fact, I mean just what one of the recent papers that I've written is exactly using AI agents in the governance process. Like I was basically said, okay, what happens if you look at this decentralized autonomous organization, which are some organizations that are set up on a blockchain where voting process is delegated to those who hold the governance tokens. And I try to understand whether or not replacing a human agent with AI agent is going to lead to the same outcome. So that means is like, can we actually simplify the decision-making process instead of like allocating this task to human, who of course have to spend some time and effort in order to make this decision? Can we simply replace the human with an AI agent who can read discussions on the board and it can make autonomous decision and see whether or not the final decision that they end up making is the same decision as the one that the human agent would. And we actually found that in many cases, they agree with the human decisions, which basically means that they are at least as efficient as the human in understanding what is the best decision process, decision. So that basically serves as a use case to understand that perhaps going forward, one could basically think of even like having a governance board, which is completely automated. But now taking a step back and understanding maybe the current reality where the decision-making process within the firm is still like left to the human. But of course, they have to take into account that some of the processes within the firm are being automated or are being executed by AI agents. Then I think it's a question of, first of all, understanding what the AI models are doing. So transparency, we need to understand precisely what is the outcome of an AI agent. If we have a model, if we regulate these models, then we need to basically see whether or not they are compliant with what one is expecting. And if that's the case, then it's easier for a governance board to understand whether or not the agents are behaving as expected. So it's not a question about how well regulated, how well validated are these AI models, so that we can make a decision whether or not some of the problems that are occurring within the firm or some of the risks that the firm is taking is well justified or not. And I think that's a question. If first the AI models well regulated, well validated, then it's easy to integrate them into the governance decision-making process. If not, then this leads to a lot of ambiguity, a lot of interpretability, a lot of risk, because of course you don't know what the an AI model is doing, and you may end up making the wrong decision. So it's all a question about having a lot of transparency, hopefully regulations around these AI models. Then I think this would simplify significantly the governance decision process.
Yeah. Look, one of the issues right now that many, especially the large banks, are facing is, if you think about it, most of them have aligned with a single model provider, right? You look at the top 5 banks, they've basically picked one model provider and said, this is our partner for AI. Obviously, you could have a existential risk for some of those companies. They may not be here in a few years, right? Or they could get bought by someone else, or the models could be deprecated, or whatever. So how should we be thinking about model concentration risk at institutions, especially as AI models go from like, hey, this is kind of fun and interesting, to a core part of their business process?
Yeah, I think you're right that the model is going to change, right? Because AI is making progress at the speed of light. So one model that you have today may be deprecated even like a month from now, right? We see that there are a lot of new developments. So as a result, it's very important to maintain this model, to have, let's say, good maintenance, making sure that when we go from one iteration to the next, we update the rules that are governing the oversight of these models. It's all a question about, it becomes also a question of accountability and traceability, making sure that there is a way to track the history of the models in a way that we understand. For example, if let's say a decision was made a month ago based on another model, and now this decision would have been completely different based on today's model, we shouldn't basically claim that there is an inaccurate description of the reality, or there has been a wrong decision process, because again, this has been made with information or with the tools that we had a month ago. So it's all a question of tracking and making sure that there is a level of sustainability across the board.
Yeah, that makes sense. And then also you bring up the question of fairness, right? Like the model said X today, it said Y tomorrow. So let's talk about that. This is obviously super important in finance, right?
Yeah.
We want to be fair. We want to be ethical. What are some ways that we can make sure that not make sure, but we can encourage fairness and monitor that, even more importantly, because there are obviously rules and laws around this too for financial institutions, right? So we've got ECOA, Reg B, the Fair Housing Act. We've got Graham-Leach-Bliley safeguards and privacy rules. There's all kinds of. They've got the CFPB has the UDAP rules. There are tons and tons of rules about, especially to do with consumers. Like, how do we make sure that these models are going to be fair? How do we monitor that?
Yeah, monitor fairness is an important question, because there are two different degrees of fairness. Like, you could just be you can write an algorithm, and this algorithm may be discriminating, for example, between different type of users based on their demographics, intentionally, because maybe it's written in the code, or unintentionally, perhaps like because of the type of request that happened, because the screening that happens in a specific point in time, it turns out that although all the best candidates are from a specific continent, and therefore they're made recommendations. So the question is like, this I view it as an unintentional lack of fairness, because maybe it was not programmed explicitly in the algorithm, but the algorithm didn't really intentionally want to be unfair. So the question is that I think if the algorithm is being unfair intentionally, because, for example, in the computer program, in the code, one has specifically stated that some, for example, like, let's say, decisions have to be made taking into account demographics, and therefore you are discriminating, I don't know, emerging market economy or things like that, then I think it's question. Then this is easy to track. So you can say, okay, this algorithm is behaving unfairly, and you can try to design some rules and regulations so that it's basically audited and it doesn't pass the test. If the algorithm instead is being unintentionally unfair, then it's a question of having maybe humans or other AI agents to supervise output, intervene on this output, understand why this output is unfair. So it's not that the ex ante was unfair, but ex post the decision turns out to be unfair. Perhaps because, again, the composition of the demographic was of a specific type, and therefore they ended up making a decision which is favoring, for example, white working people, let's say. Then in that case, you could try to modify the algorithm and somehow make sure that if it happens to, if the circumstances happen to be the ones that we're observing today, then you would have ended up in a different state, in a different decision-making process, because you change in a way the rules. Instead of being, let's say, optimal, because when we define optimality of a decision-making process of an algorithm, we need to define optimality not just in terms of, let's say, maximizing the outcome, but also, let's say, changing the outcome in a way that it takes into account also this fairness. And I mean, that is something that I think one can iteratively modify, right? It's not something that, I think it's impossible to design an universally fair algorithm, both ex ante and ex post, but I can see that you can define an algorithm that is fair ex ante all the times, and which is increasingly more fair ex post by a sequence of. So every time you see an outcome, just observe the outcome, process the outcome, see if it's fair, if it's unfair, go back and change decision-making logic of the app. So I view this as a feedback process. I don't view it as, let's say, a standalone process that you deploy once and then the outcomes.
Yeah. And look, blockchain and AI are going to converge over time. We talked about AI agents doing your shopping for you. Maybe they're using stablecoin to purchase it.
Yes.
What do you think is are the key risks there of the convergence of AI with blockchain, or frankly, blockchain or cryptocurrency in general? Just what are the key risks there that you think about?
Yeah, but this I think is really one of the topics that I'm currently looking at now. In fact, I'm planning to hold an event exactly on understanding the intersection of AI and Web3 and blockchain. I mean, first of all, I think I can see that going forward, there will be more and more use of cryptocurrencies to make payments on e-commerce platforms. And here, when I say cryptocurrency, it could be that we just use, let's say, the stable coins, which are regulated, so processed for being used, or it could be Bitcoin, could be Ethereum, but it could also be that each of the company issue their own coin, and as a result, I can imagine that, let's say, Walmart, Amazon, Google, they have their own coin, and then I can use these coins to make payments, and I can use these coins to also trade or exchange currency. So that's, I think, the difference with respect to the loyalty program. Like I use a Google coin to make a payment, but maybe I can swap my Google coin for an Amazon coin and then be active on Amazon and make payments with Amazon. So I can see this being a big shift going forward. I wouldn't be surprised if 1 year from now we are using digital coins to make payments on e-commerce. And then I think in terms of the AI for blockchain, I can see that there will be more and more use of AI, for example, to design new marketplaces on blockchains, including understanding, for example, how to replace this governance process within decentralized autonomous organization, which is one of the studies that I've currently already done. I can see also a very promising applications of AI for designing smart contracts. So when we think about smart contracts, typically right now you need to be able to program it using Solidity or other other software engineering code that maybe not everybody's familiar. But what happens if we try to use any AI agents to deploy, design, and develop a smart contract? This was one of the projects that I've done this semester with a student, where we have tried to use agents to basically replace completely the logic of a smart contract. So if you have to invoke a function, make a payment from this address to this address, I want to delegate this task to an agent. And I want the agent to learn how to do that. Maybe the first time it takes you this task, it makes a mistake, but then it learns, it self-corrects itself, and it keeps improving over and over. I can see that this will be really a game changer, right? Both in terms of AI for blockchain, but I think I can also see a value of blockchain for AI. So we can use blockchain, for example, to host high performance computing capability. And I can see blockchain also as infrastructure to support energy efficient computations in the AI algorithms.
Oh, excellent. So Agostino, our time is up. Why don't you tell our listeners where to find you, where to find the Center for Digital Finance and Technologies at Columbia? What are the best sources to find your papers too?
Yes, I think the best sources to find my paper is always visiting my website. I think if you go to columbia.edu and you write Agostino Capponi, you will see me right away. And I think there is also on my homepage, there is a link to the Center for Digital Finance Technology. But actually, the Center for Digital Finance Technology can also be found very easily if you just write godigital.engineering.columbia.edu. So you will see it right away. The center, you will see a number of papers that can be produced by members of the center, including my own work. And you will see also a lot of open source software that we have released. And if you're interested and want to be up to date with the events that we are organizing, you can sign up on the digital mailing list and you will receive notifications about events.
Amazing.
And I'm really looking forward to learning more from you as well. If you're interested, get in touch.
Excellent. Well, thank you for coming on the show. This has been Professor Agostino Capponi from Columbia University and Director of the Center for Digital Finance and Technologies. Awesome thoughts. Great to have you on the show. Thank you for your time.
Thank you so much, Alec. That has been a pleasure and a very interesting conversation. Thank you.
You are listening to the AI Risk Reward Podcast with your host, Alec Crawford. You can find us anywhere you listen to podcasts, for example, Apple Podcasts. Production and sound engineering by Troutman Street Audio. You can find them on LinkedIn. Please like, subscribe, and comment.